wanted to get to the example that we didn't quite get to in class. And that was example 4 from our proof section on the section 4.2 notes. So this one has given us, and we actually did do this one, just not as a proof, in our notes. So we have been given that AE and BD bisect each other. So remember, bisect means that it's cutting in half or cut into two congruent parts. So if they're bisecting each other, that means one's being cut in half and the other's being cut in half. So for example, AE is cutting through DB. So we would put a congruent marking on DC and on CB. Let's write that in our proof before we go on. So let's say segment DC is congruent to segment CB. What did I use? I used the word bisector, which means I'm using the definition of that word. Now you cannot say definition of a bisector. It's definition of a segment bisector. I'm just talking to myself on the video. So.
Yeah. Just got this all the time.
All right, now we have to remember they're bisecting each other, which means that also BD is bisecting AE, which means AC is congruent to CE. We actually can write this on the same line of the proof because it's the same reason. If you prefer, you can write it on the other line and then repeat the reason. Okay, so now I've taken care of all of my given. Now I have to look at the picture and see what else I know. I don't have a shared side, but I do see some angles. I see vertical angles. So I can mark those. I cannot call them angle C though because there's multiple angles touching C. So I could call this angle ACB or BCA. So angle ACB is congruent to either ECD or DCE. The angle doesn't matter, the triangles do matter. But to be consistent, ACB, I'll do ECD. And that would be our vertical angles theorem. Or vertical angles are congruent. Now we have SAS, SAS. So we are done. We would copy our proof statement down here. That would be our SAS postulate. The flowchart had said draw and label two triangles that are congruent by SAS, and we're also marking them. So we label them TSU, WVB, and we want to mark them by SAS. So I'm going to have one congruent side, an included angle, and another congruent side. This is one example of what it covers.